Okay, so in preparation of a buffer solution, you first need to decide how much and what pH you want to make. So we'll hypothetically say prep 250 milliliters of buffer with pH equal 7. So we'll do one right in the middle and so forth. Well, the first thing you need to do is find the components of your buffer solution, and we're going to make this one out of carbonic acid and bicarbonate, maybe a sodium HCO3 minus. And you need to, and the reason I chose this is because the pKa of the acid that you're selecting is approximately 7. That is, this one is specifically listed at 6.8. So you need, when you just, if you want a 7, this is kind of a backwards calculation. If you want a 7, you need to find a salt, an acid with a K value, a pKa, close to whatever the pH is. And if you pick, say, acetic acid, its Ka is 1.8 times 10 to the minus 5. Its pKa minus log of the Ka value and that's 4.74. So that's not very close to the pH of 7 that you want to prepare your buffer with. So a better choice would be to find the first ionization step of the carbonic acid. And I've got Ka is 4.2 times 10 to the minus 7. So if you want to back calculate it. Okay. Now the next thing you do is try to calculate the acid-base ratio. So you've got an acid, and the salt of that acid, the sodium bicarbonate, is the base of the buffer, the anion. Remember I said all anions are conjugate bases, this kind of thing. Well, to do that, you use the Henderson-Hasselbalch equation. Kind of spelled weird, but B-A-L-C-H is correct, Bloch. Anyway, a Henderson-Hasselbalch is the pH of a buffer is equal to the pKa of the acid plus the common log, base 10, of the base concentration divided by the acid concentration. Right there. Now this is a relatively easy type pre-calculation, a pre-mix calculation. Once you decide on what you want to use, you've got the pH, the desired pH is 7, so we come in here, put it 7, and we found a compound acid. First ionization would give us a pKa of 6.8 plus the log of the base concentration over the acid concentration. And so I solved for log of base over acid to equal 7 minus 6.8, and that gives me a 0.20. Now from here I need the base acid ratio, so if you're going to undo a logarithm, it is 10 to whatever the log value is, and it'll be 10 to the 0.20. And you put 0.20 into your calculator and take that as a power of 10. And so let's stop right. So that comes out 1.58 base B over A, base over acid. Now, what this tells you right here is that the base concentration needs to be 1.58 times larger or stronger than the acid concentration. Like that. Contains a 1.0, say, molar of acid plus 1.58 molar ratio in base, like that. Next thing is to determine how many grams of each one you will need. You remember the equations we used? Okay, so the next step is determine the grams of each reagent you need. And of course that's carbonic acid and sodium bicarbonate. And so how many grams of sodium HCO3 solid will we need to make a, I don't know, we'll do the fraction if you want to. It won't be a 0. Well, to yield 250 milliliters of a 0.158 molar solution. Now you take each one separately as if you were just making that solution only, and figure how many grams of stuff you need. Okay, grams sodium HCO3 needed is equal to what molarity that you're looking for, which will be the 0.158, okay? Volume that you're looking for in liters times the formula weight of the salt, okay? Divided by the purity factor. We do the same thing for the carbonic acid when you get there. And you mix the salts together and then dilute up to 250. See? So we're looking for a 0.8 molar solution. We want 0.250 liters, and grams per mole. Purity factor, I'm going to give it a 1.00. 100% pure. But be sure to check the assay of the manufacturer to be sure. I get 3.318 grams of sodium bicarb. I'm going to put it in one beaker or weight boat, very carefully getting that mass. Then you need to get do the same thing for the carbonic acid. Grams of H2CO3 now is equal to the same issue, molarity times volume of the buffer solution times the formula weight divided by the purity factor. And in this one, the carbonic acid would be a 0.1. It's a 158 to 1. 0.158 to 0.1. So the molarity we're looking for is 0.100 molar in the carbonic acid. We still want the 0.250 0.250 liters, and it's 62 grams per mole. And we'll say again the purity factor is 1.00 for that one. Separate the two to be sure you see them clearly. So your job is to weigh out 3.318 grams of sodium bicarb or hydrogen carbonate and 1.55 grams of carbonic acid. Pour them in a beaker and dilute up to, but not to exceed, 250 mils, and you'll have your buffer made. Okay, so your buffer mix now is, from the calculations, 3.18 gram of sodium bicarbonate. You'd weigh it out into the weight boat, number one. Weight boat number two, you'd put 1.55 gram of carbonic acid in the second weight boat, and then pour them in the mixing container and dilute up to, but not to exceed, 250 milliliters, and that will be your pH equal 7 buffer. Okay, here's a recap on that. This is the shorthand method. Select your pH that you need, that you're interested in. Select a weak acid with a pKa close to the pH that you need. Then you apply the solution formula for the grams. Then you mix the solids together and dilute up to your desired volume. So, not a real complicated issue if you understand what this is all about, and can make life a lot easier. I have a kinetics experiment that pH has got to be controlled very, very closely at the beginning of it at 7. So when I make my reaction solutions, I make them so that they're stable at pH 7.